Imagine you could prove something is true without revealing any of the secret information behind it. I know, it sounds a little bit like magic, doesn't it? Well, that's exactly the power of zero-knowledge proofs, or ZKPs. This is a pretty revolutionary technology that's completely changing the game for privacy and security online. Let's dive in.
So to really wrap our heads around this, let's start with a really simple real-world problem that ZKPs are perfectly designed to solve.
Okay, picture this. You're buying a car. The seller, naturally, needs to know that you actually have the funds, but you really don't want to show them your bank statement. I mean, that would reveal your salary, your spending habits, your exact balance. How do you prove you can afford it without opening up your entire financial life? This is the exact puzzle that zero-knowledge proofs solve.
A ZKP is basically like a cryptographic magic trick. You, as the prover, can show the car seller, the verifier, that you have the money, and they learn literally nothing else. Not your balance, not your other transactions, just a secure mathematical yes. It's all about verification without revelation.
And you know, this isn't some brand new futuristic tech. ZKPs were actually first dreamed up way back in the 80s at MIT. For the longest time, they were just this fascinating idea on paper. But now, with the rise of blockchain and the need for digital trust, they've jumped from theory to reality and are quickly becoming a cornerstone of Web3.
So how do these proofs actually work? What is it that makes them so secure and so private? Well, it all comes down to three fundamental mathematical properties.
First up is completeness. If you're telling the truth, you can always generate a valid proof. Simple enough. Second, soundness. If you're lying, you absolutely cannot fake a convincing proof. It's just mathematically impossible. And third, this is the secret sauce, zero knowledge. The proof reveals absolutely nothing other than the fact that the statement is true. These three things working together are what makes ZKPs such a game changer.
So, what can we actually do with this incredibly powerful tool? Well, in the blockchain world, ZKPs are being used to tackle two of the biggest challenges out there.
First, there's scaling. Projects like ZK-Sync use ZKPs to bundle thousands and thousands of transactions into a single tiny proof that gets posted on-chain. Think of it like a super-efficient carpool for data. It makes everything dramatically faster and cheaper. Then, on the other side, you have privacy. Projects like Zcash use ZKPs to completely shield transaction details, giving users true financial confidentiality. So you get two massive benefits, speed and secrecy, all from the same core technology.
Now let's get just a little bit more technical. When developers want to build with ZKPs, they generally have two main flavors to choose from, and each one comes with its own set of pros and cons.
We've got ZK-Snarks and ZK-Starks. The main difference? Snarks are really small and efficient, but they require something called a trusted setup. That's a one-time cryptographic event that has to be done perfectly to keep the system secure. If it's ever compromised, the whole system is vulnerable. Starks, on the other hand, create larger proofs, but they don't need this setup at all, which makes them more transparent. Plus, they're believed to be resistant to attacks from future quantum computers. So it's this classic trade-off between efficiency today and security for tomorrow. Okay, this is not just abstract theory. ZKPs are already having a huge impact in the real world, and honestly, the numbers are pretty staggering.
Just take a look at ZK-Sync. This is a network that uses ZK technology, and right now it's securing over 4 times $1 billion in assets. This isn't test money. This is real, live economic activity that's relying on the security of ZKPs every single day. And it's not just about the money locked up. ZK-Sync has already processed over 700 million transactions. This proves, without a doubt, that ZK technology can handle massive scale, making it a powerful, production-ready engine for a more efficient digital economy.
And the tech is evolving incredibly fast. We're now seeing the rise of what are called ZK-VMs, or zero-knowledge virtual machines. This is a huge leap, because it means we can prove that any computer program ran correctly without revealing any of the inputs. Now think about what that enables. Using something called ZK-TLS, you could prove you have a certain balance in your real-world bank account just by visiting their website without revealing your login info or account details to anyone. It's a secure bridge between the internet we use every day and this new world of verifiable trust.
And the world is really starting to take notice. We're talking big names like Deutsche Bank and Visa exploring ZKPs for finance, while governments are using them for everything from digital IDs for millions of citizens to experiments with secure online voting.
This technology is going mainstream, and it's probably going to affect all of us. As this quote makes really clear, the whole conversation has shifted. ZKPs are no longer just some niche cryptographic experiment. They are quickly becoming a foundational layer of the Internet's infrastructure, paving the way for a more secure and private digital world.
So, what's the big takeaway here? Zero-knowledge proofs are so much more than just a cool piece of tech. They really represent a fundamental shift in how we establish trust and manage privacy online. So I'll leave you with this. What happens to our world when we can verify anything without having to reveal everything? The possibilities are pretty much endless, and believe me, we are just getting started.